Hi there and welcome. My name is Rebecca Weaver, and we are going to be graphing linear inequalities today. So, on the first little bit of the homework, they're going to give you some sort of inequality, and they're going to ask you to decide if the following ordered pairs are solutions to the given inequality. So, we look at our inequality. It's y is greater than x plus 2. I can look at this and see that the slope is 1 and the y-intercept is 2. So I need to determine if all of those different points are solutions. So let's look at the points one at a time. If I have the point 0, 1, let's just plug that into our inequality. Wherever there's a y, I'm going to put the 1. Wherever there's the x, I'm going to put the 0. So I have 1. Is that greater than 0 plus 2? Is 1 greater than 2? No, that's not a solution. All right, so I'd say no on that one. So in this next point, x is 2, y is 1. Let's do the substitution on that. I have 1. Is that greater than 2 plus 2? Is 1 greater than 4? No, that's not a solution. Well, let's try x is 5, y is 8. Plug that in. Is 8 greater than 5 plus 2? Is 8 greater than 7? Yeah, it is. That's a solution. All right, what if x is negative 2 and y is 3? Let's plug that in. Is 3 greater than 0? Yeah, that's a solution. Let's look at negative 2, 0. If x is negative 2 and y is 0, plugging that in, ooh, is 0 greater than 0? No, it's not greater than or less than. He's equal to, so he's not a solution. What about if y is negative 3 and x is negative 2? That would give me is negative 3 greater than 0? No, that's not a solution. What about 0, 0? Is 0 greater than 2? No, that's not a solution. Now let's look at this if we were to graph it, because we're going to be asked to graph these inequalities. Graph them just like we do a line. If my slope is 1 and my y-intercept is 2, I'm going to graph the 2 first. That's my y-intercept. I'm going to go up 1, run 1, make my dot, draw my line. Now I drew a dashed line because y cannot equal this line. So this is kind of like my boundary line. And I see that my y is greater than this line. So I'm going to shade above. Now what in the world does this mean? If I shade above, that means all those points above are solutions to this inequality. So let's look at our point. Let's look at 0, 1. There he is. We said he wasn't a solution. See how he's not in the shaded part? Let's look at 2, 1. See how he's not in the shaded part? He's not a solution either. What about 5, 8? If I were to graph 5, 8, he's in the shaded part. And you know what? He was a solution. What about negative 2, 3? There he is. He is in the shaded part, and yes, he was a solution. So when I plop the last 3 points down, they better not be in the shaded part. Now this one, negative 2, 0, is right on the line, and we said it couldn't equal, so that one is not a solution either. And there we have it. Notice that any of those points that are in the shaded section would be solutions to this particular inequality. So let's look at another one. Y is less than or equal to 2x minus 2. For this one, slope is 2, y-intercept is negative 2. I'm going to draw my negative 2 point. Then I'm going to go up 2, run 1, draw my line. Now this is less than or equal to, so I'm going to draw a solid line here. Then y is less than this line, so I'm going to shade below. And this would be my solution. Now let me just try a test point because I want to make sure that this works. My favorite test point is 0, 0. So I'm going to put that dot down. I'm going to check it and make sure it doesn't work because sometimes it's easy to get flip-flopped and shade the wrong side here. So I want to make sure. So I'm going to plug that into my inequality. Is 0 less than or equal to 2 times 0 minus 2? In other words, is 0 less than or equal to negative 2? No, it's not, and I didn't expect it to be because it wasn't shaded. All right, so let's look at another one. We have y minus 4 is less than 3x. Now, I don't like it in this form, so I'm going to add 4 to both sides so that I can get it in that y mx plus b form. So let's add 4 to both sides, and I'll have y is less than 3x plus 4. In this, the slope would be 3. The y-intercept would be 4. I'm going to draw my dot at 4. I'm going to go up 3, run 1. And this is going to be a dashed line because it is strictly less than. And since y is less than, I'm going to shade the underside. It's below. Less than is below. So I need to check my test point, which is 0, 0. There he is. I'm going to plug him into my inequality. Is 0 less than 3 times 0 plus 4? And I'm going to say that it better be because I've shaded that bottom section. So let's see. Is 0 less than 4? Yes, it is. So I'm happy there. Let's look at another one. Ooh, y is greater than 4. For this one, I just go to where y is 4 because I don't really see where my slope and y-intercept are, but I know that y is 4. So I'm just going to draw a dot where y is 4. Draw another dot where y is 4. Oh, this is one of those horizontal lines. Since it's greater than or equal to, I'm going to draw a solid line. And greater than or equal to means I'm going to be shading above. So there we've shaded above. Now I need to do a test point just to make sure that I've shaded the right section. I always like 0, 0. And there he is. Is 0 greater than 4? No, he's not. So I wouldn't expect the point 0, 0 to be shaded. Cool beans. All right. If you have any questions, be sure and email me. Have a wonderful day.